I think it is not permission to record this one, because to record it one, I will have to log through the account. Then if you need the recording, then shall I log out and log into again? Or else tomorrow session I can record and share with you. Okay, same session we'll have tomorrow. Then the tomorrow session I will record and I will share the recording with you. Is it okay? Okay. Then today mainly I'm going to explain the concept of shape of the distribution. I can explain it with a very simple example. Now in Excel sheet, you can see a data set. Let's say this is number of cars sold per day. Let's say in a one car sales company, they have 3 centers. Let's say one center in Colombo, one in Kandy, one in, let's say, Goal. There are 3 centers. Then they have collect number of cars sold per day. Okay. Then here 0 mean no sales. No sales. In a center 1, there are 40 days with 0 sales. In center 2, there are 20 days with 0 sales. In center 3, there are 2 days with 0 sales. Then if you take 1 sale, in the center 1, there are 100 days with 0 sale. Okay. Then in the center 2, there are 40 days with 0 sale. Center 3, there are 8 days. Altogether, they have collect information related to 500 days. Here 500 days, then how is it count? Yes. In these 2 centers 500, then here 940 days. Okay. Then now if you take the center 1, what is the situation in the center 1? You can see there are more days with low or small low, there are more days with less sales. There are few days with high sales. And also if you take center 3, there are only few days with less sales and there are many days with high sales. Then if you graph this information, let's say this one, this is the graphs related to distribution of sales in center 1. And you can understand it. 1 sales, 40 days. 2 sales, how many days? 2 sales, 100 days. Like this is the distribution related to center 1. In the center 1, more observations are with lower values. More observations are with lower values. Observation means number of days. We have more number of days with lower values. Now you can see the shape of the distribution. You have a tail in the right side. You have a tail in the right side. Okay. This is we call right skewed distribution. Right skewed distribution. If the tail is in the right side, you have less observations with higher values. Less observation with higher values. Here our variable is number of cars sold per day. Then you can see there are few days with higher sales. Few days with higher sales. Then the curve is right skewed. Now how about this one? This curve related to center 3. It is completely different. It is completely different. What is the situation? You can see tail in left side. Then we call this is left skewed distribution. We call this is left skewed distribution. Why we have left skewed distribution? You can see we have less observation with lower values. Low values mean number of cars sold. 2 days with 0 sale, 8 days with 1 sale, but you have high for many days with higher sale. Then the distribution is we call left skewed. There are more observation with higher values. How about the center 2? It is something like this. Center 2. We can say it is a like symmetrical distribution one, or it is a bell-shaped one. Frequencies are symmetrically distributed. You can see lower sales 40 days. Then here again, you can see higher sales also 40 days. 60 days, lower sale, higher sales also 60 days. Like this, the distribution is symmetrical. Okay. I think now you may have idea about the shape of the distribution, why we are having different shapes. Mainly, we have 3 shapes. Symmetrical, this one we call symmetrical. If you have a distribution like this, we call left skewed. If you have a distribution like this, we call right skewed. Okay, these are the 3 different shapes of the distributions. Then, this is the graphical presentation. Then we have some measures or indicators to identify the shape of the distribution. Then we will move to our PowerPoint presentation. If you have any doubt up to this point, you can raise. No doubt. Zoom lagi mau lain mana? Zoom lagi lain mana? Nah, ini lagi.
අපේ තියෙන ෆොටෝ බලන්නත් මේ සිග්නල් ඔය ඩේටා වලින් මේ තියෙන ෆොටෝ බලන්න යතෝනේ ඉතින් ඕනේ ආහම සිග්නල් නැති තැන හරි ගියාම ඉන්නේ ඉවි 100 ඉන්නේ
Hello, okay කවුද? ඔයා මොකද ඉයර එක? sorry, I had a technical issue. I was unable to share the screen. I think in the last session we discussed up to this point. Then the shape of the distribution. There are two useful measures, skewness and kurtosis. Then skewness describe the amount of asymmetry in the distribution. That means with the skewness, you can identify whether distribution is left skewed, symmetric, or right skewed. Left skewed mean, as I explained, we have a tail in the left side, then the mean is less than to median. If it is symmetrical, mean, median are equal. If it is right skewed, mean is greater than median. Then when you calculate skewness, it is minus or less than 0 for the left skewed. If the distribution is left skewed, the value of skewness is minus. Here 0, here plus. Then this is the formula you can calculate skewness. Okay. But normally we don't want to calculate these values because with the computer software, using Excel or any other software, you can get the value of skewness. Then if the value is 0, the histogram is symmetrical. As I showed earlier, it is symmetrical. Then we have positive skewness and negative skewness. Positive skewness means there are more observations below mean than above it. There are more observations below mean. Positive skewness means the shape is this one. Positive. There are more observations below mean. As in our example, we observe center 1. There are more days with less sales. Then the distribution is right skewed. The distribution is right skewed. There are more observations below the mean than above it. Mean is here, median is here. Then 50% below median and another 50% above median. Then if you take mean, more than 50% observation below mean. Then the negative skewness mean there are a small number of observation with low values, large number of observation with high one. It is like this. Left is skewed or negative. Left is tail is in the left side. Median is greater than mean. I think I explained these things earlier also. Then the next concept is kurtosis. It measures how big the histogram is. It measures how big the histogram is. The kurtosis of a normal distribution is 0. Kurtosis characteristics the relative weakness and flatness of a distribution compared to the normal one. When the kurtosis is negative, frequencies throughout the curve are close to be equal. It is something like this. It is frequencies are equal. Flat curve. Negative kurtosis indicate relative flat distribution. Distribution is flat. Then the positive kurtosis indicate there are high frequencies, only a small part of the curve. You can see here negative kurtosis and positive kurtosis. High frequencies in a small part of the distribution. most of the observations are scattered and equally distributed. The same things we can explain here. Then this shows how we can get these values from Microsoft Excel. Let I will do this exercise. Then the next concept is quartile. Quartile split the rank data into 4 segments with an equal number of values per segment. Let's say if you have 100 observation, you can identify Q1 first quartile where you have 25 observation below this value. Then the Q2 is actually median. There are 50% observation below median and above. First quartile is the value for which 25% of observation are smaller and 75% are larger. Like Q2 is same as median. Then the Q3, only 25 of the observation are greater than third quartile. Then this is the way to identify first quartile. N is the number of observation, n plus 1 divided by 4, first quartile position. And the second quartile is the median value, n plus 1 over 2. Third quartile, n plus 1 over 4 into 3. Then we have another concept called, now this is way to how we calculate it. When the calculating the rank position used, we'll have to use the following rule. If the result is whole number, then it is the rank position. If the result is fractional half, then we can get the average of 2 corresponding values. If the result is not a whole number or fractional half, then round the results to nearest integer to find the rank position. That means when we calculate, or when you calculate the quartile position, let's say value is 6.5. Then you can take the value of 6 and 7 and take the average. If it is 6.2, then when you round up it becomes 6. Then the quartile is the value in 6th position. If it is 6.9, when you round up, it becomes 7. Then this example shows how to identify first, second, and third quartile. Then the first quartile is 12.5 here. Second one is 16, third one is 19.5. I hope you can understand. Then we have another concept called interquartile range, where the difference between first quartile and third quartile. It measures the spread in the middle 50% of data. IQR is also called mid spread because it covers middle 50% of data. Then IQR is measure of variability that is not influenced by outlier or extreme values. Measures Q1 and Q3, and IQR that is not influenced by outlier called resistance measure. Then this diagram summarizes 5 numbers we learned: minimum, maximum, first quartile, second quartile, and third quartile. Let's say maximum value is 12. Minimum value is 7. Then if the mean is 30, sorry, Q1 is 30.
Sir, we can't see the screen. See on the previous slide.
Now what you can see? Hello.
In the slide slides, quartile measures.
Now?
Now, okay.
Okay. Then this chart has summarized 5 measures we learned. Minimum, maximum. In a data set, the minimum value is 12, maximum value is 7. Then the first quartile 30, which indicate that there are 25% observation between minimum and first quartile. Then the second quartile 45, it indicates that there are 50% observation below median and above. Then the Q3 third quartile 57, it indicates that there are 75% of observation below third quartile and only 25 above. Then the difference between these two we call interquartile range. Okay, then we will move to very important concept we call 5-number summary. Using this 5-number summary, we can develop or we can draw a conclusion related to shape of the distribution. If you are given these 5 numbers, you should be able to identify whether you have a symmetrical distribution, whether you have a left skewed, whether you have a right skewed. Now I'm going to explain how we can identify the shape of the distribution if you are given these 5 numbers. I think these 5 numbers are familiar to you now. The smallest mean minimum value, largest mean highest value, median is the middle value, first quartile below 25% we have, third quartile 75%. Okay, then it's in this chart. Then please try to understand this chart. I'll give maybe 5 minutes while I'm coming with a cup of tea because teaching through the online is very difficult than on-site teaching, because if it is a 2-hour continuously, the teacher have to speak. Then it's a little bit difficult because no one is speaking from the student side. Okay, please try to understand this chart. Maybe within 5 minutes, I will start my discussion. Now, do you have any idea about okay then? Now, do you have any idea about why left is skewed and right is skewed? If the distribution is symmetrically distributed, it is something like this. Then we can say this is the minimum value, this is the maximum value. Then the median, mean is here. If it is symmetrical, mean equal median. Mean equal median. Then what do you mean by median minus smallest? Median minus smallest. That means from here to here. This distance is equal to this. If the distribution is symmetrical, when you subtract smallest value from median and largest median from largest value, both values should be equal. Then the second condition is Q1. Q1 mean second quartile and Q3. Then Q1 minus smallest from here to here should be equal largest minus Q3. This is the second one. Third one, median minus Q1. This part should be equal Q3 minus median. That means if the distribution is bell-shaped, these four segments are equal. Then you can understand the situation of left skew. It is something like this. Left skew. Then this is the minimum, this is the maximum. Then where is the median? It should be somewhere here. Because we should have 50% observation this side and this side. Then the median minus smallest, this section, is greater than median minus largest. Like this, you can understand other three also. If it is a right skewed, then it is the minimum, then the median should be somewhere here. Median minus smallest is okay, then this is the median, this is smallest. Median minus smallest is less than largest minus median. Then now you can see if you are given these five numbers, median, smallest, largest, Q1 and Q3, you should be able to identify the shape of the distribution. Is it clear? That means the sound is, one say that sound is not clear. Is it okay now?
No, okay.
Okay. Then based on five numbers, we can derive or we can draw box plot. This chart we call box plot. It summarizes five numbers. Smallest, Q1, median, Q3 and largest. In the box plot, this line shows the smallest value, this shows largest value. Q1 is in the middle box, the starting point is Q1 and ending point is Q3. Then the middle line in the box shows median value. Now I'm going to ask a question from you. Now, this is a box plot related to one data set. So my question is, what would be the shape of this data set? Whether it is a right skewed, left skewed, or symmetrically distributed one. Any answer? Then by looking this box plot, now you should be able to understand or identify the shape of the distribution. Yes, any answer?
Left.
Yes, left skewed. Why you call left skewed? Then you can see the difference between smallest and Q1 is higher than largest minus Q3. And Q1, median to Q1 is greater than median to Q3. The distribution is something like this, left skewed. Tail is in the left side. How you can identify it? Now you can see tail this side. See, compare these two. Left skewed. Okay, then what you can say about this one? Then you can see here all are identical. No? Then this should be a symmetrical distribution. Then you can see symmetrical distribution, right skewed and left skewed. Then this is a distribution related to left skewed. So right skewed. Tail is in the right side. Is it clear up to this point?
So in terms of the number of observation, is it equal every quarter?
Yes, number of observation. Yes, now yes, number of observation. Now let's say if you take Q2 is the middle, there should be a 50% observation below this and 50% above. This actually, this distance does not show the number of observation. It shows how it deviates. Then you can see Q3 is 5, but the largest value is 27. That's why we have a large tail here. But there are, since this is Q3, there should be 25% observation above this value. I hope you got the point.
Yes, sir. Thank you.
Okay, then actually we discuss some measures related to sample. Same measures we can calculate related to population. When it is related to population, we use different symbol. As example, we calculate mean, average X. This is for sample. If it is for population, the symbol is this one. This shows population mean, this shows sample mean. Only different is symbols. Then population variance, we use this symbol. Sample variance, we use S square. Then the standard deviation, we use SD for the sample, OS. Now here we use this symbol. Then you will have to remember, if you are given this symbol, this indicates population. And similarly, if you are given this one, this shows population value. If you are given this value, it is population average or mean. Okay, then we will move to another concept. It is we call empirical rule. If the distribution is normally distributed or bell-shaped distribution, there are 68% observation within 1 standard deviation from the mean. That means it is something like this. Let's say mean is 50. Let's say standard deviation is 10. Then within 1 standard deviation means 60 to 40. 60 to 40. Then if the distribution is bell-shaped, there are 68% observation should be 40 to 60. This we call empirical rule. This one we will further discuss when we discuss continuous distribution. Then within 2 standard deviation from the mean, there should be 95% observation. 3 standard deviation from the mean, 99.7% observation. Then example, suppose that variable max static score is bell-shaped with mean 500 and standard deviation 9. Then 68% of all test takers score between 410 to 509. That means 1 standard deviation, 500 minus 9. 500 plus 9, because standard deviation is 9. Then 68% of students are within this range. 95% of students are in this range. 99% students are in this range. Then we have another rule we call Chebyshev rule. It will be difficult to pronounce, but the concept is this rule you can apply for regardless of the shape of the distribution. Empirical rule is applicable only for normal distribution. This you can apply for any type of distribution. This says that at least 1 minus 1 over k square into 100 of the values will fall k standard deviation of the mean. K should be greater than. Now let's say 2 standard deviation. When you simplify this, it is 75%. Then according to this rule, regardless of the distribution, whether it is symmetrical, left or right skewed, at least 75% observation within 2 standard deviation from the mean. Then 89% observation within 3 standard deviation from the mean. Then we will move to another very important concept. It is we call covariance. Covariance measure the linear relationship between 2 numerical variables. That means this concept helps you to understand the relationship between 2 numerical variables. Let's say as example, you can consider 2 share prices of 2 companies. Let's say company AC and AD, 2 companies. Then you want to see, are there any relationship between share price of company AC and share price of company AD? To see this, to identify this relationship, you can use the concept of covariance. This is the formula to calculate covariance. It is only concerned with the type of relationship. It shows that whether we have a positive relationship or negative relationship. No causal effect is implied. That means it does not show whether one variable affect on other. Just it shows whether they are changing in same direction or opposite direction. When the covariance is positive, we can say 2 variables change into same direction. When the covariance negative, 2 variables change into opposite direction. Covariance 0, x and y are independent. Okay, then sometimes you may think that why when the covariance is positive, both change into same direction. If it is negative, 2 variables are changed into opposite direction. Then I can further explain this concept with an example. Okay, then we have two variables x and y, Then this shows x bar average value, this shows y bar average value of y. Then now I will take one observation here. Then the covariance we calculate x minus x bar into y minus y bar, and we get the summation of it. We get the summation of it. Then, now related to this observation, if you calculate x minus x bar into y minus y bar, what is the sign of this value? Not the value, sign of this answer. X minus x bar. X value is here. X bar is here. X minus x bar, whether it is minus or positive, plus value or minus. X is here. X minus x bar. Yes. This should be minus. Y minus y is here. Y bar is here. Then it is also minus. Then minus into minus plus. Then if you have observation here in this box D, when you calculate covariance, it's become plus. Is it clear? Then similarly, if you take observation here, now x is here, x bar is here, y is here, y bar is here. Then what is the value of y, x minus x bar? X is greater than x bar, then it is plus. Y minus y bar, it also plus. Value plus. Then if you have observation in this segment, covariance is positive. That means now you can see these two variables have positive relationship. That means both variables change into same direction. When one increase, the other one also increase. One increase, other one also increase. Okay. Then now you can realize what happened if the observations are scattered here. Then covariance become negative. Because if you take this observation, y is here. The y bar is here. Y minus y bar is plus, and x minus x bar is negative. Then minus. Like this, the value become minus. That's why we call, if the covariance is positive, we have a positive relationship between two variables. That means both variables change into same direction. Is it clear? Hello. I hope you got the point. Okay, then xy tend to move in same direction. That means both change into same direction, and it is we can say positive relationship. X and y tend to move in opposite direction, negative relationship. The major limitation of this covariance is it is not possible to determine relative strength of the relationship, whether it is strong relationship or weak relationship. We can't identify. Then to overcome this limitation, we have another concept called coefficient of correlation. Once you divide covariance by standard deviation of X and Y, you have a correlation of coefficient of correlation. Then these are some important facts related to correlation, coefficient of correlation. If you calculate coefficient of correlation related to population, it is the symbol. If it is related to sample, this one. Then the value of correlation coefficient is -1 to +1. If it is -1, or if it is close to -1, we have a stronger negative linear relationship. Close to 1 +1, stronger positive linear relationship. Close to 0, weak relationship. Then this diagram shows correlation coefficient and the relationship between X and Y. Now this is we call perfect negative relationship. All observations are in a straight line. Perfect positive relationship. All observations are on a straight line. Zero correlation. All are in the straight line, but when X change, Y does not change. No relationship. Value of X has increased, but Y is constant or same value. Then this is, we can say, negative relationship, weak or moderate negative relationship. This is, we can say, positive relationship, but it is weak because value is less than 0.5. If it is less than 0.5, then we can say weak relationship. This one we can't say weak because value is greater than 0.5, then we can say moderate relationship. Okay, then the Excel presentation we will do later. And this is the end of today's discussion and end of discussion related to descriptive measures. In the next week, we will do some practical session related to descriptive measures where you can learn how to calculate all these measures using Microsoft Excel. Now I'm going to wind up the session. We have actually another 30 minutes, but the session is over, and also in the next week we can start the next session. Okay, shall I wind up the session?
Okay, so thank you.
Yes, sir. Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.